So students, in the last part, we are going to discuss the network services abstraction layer. So diagrammatically, you can see here. Here is the network services abstraction layer. So this layer is between what? Between the application plane here uh, and provide an abstract view of the network resources here that hides the detail of underlying data plane devices. The detail is hidden because of the network services abstraction layer. It hides the detail. So an abstraction layer is a mechanism that translate high level request. Students, high level request, we talk about the software at the high level, into the low level commands required to perform a request. An API is one of such mechanism. Which API? Over here we talk about the REST API. Second, student, this network services abstraction layer, it basically it shields. Shield means it protects. It protects the implementation detail of lower level from the software at the higher level. So network abstraction represents the basic properties or characteristic between the features of network entities in such a way that the network programs can focus on the desired functionality without having to program the detailed action. So they focus on the desired functionality only without having the program in the detailed actions. So student, frenetic is one of the example of the our network services abstraction layer. So frenetic, it's here in front of you, is an example of network services abstraction layer. Is the programming language. So frenetic is a programming language. So it is also a domain specific language. What is a, first of all, we should know what is a domain specific language. Is a computer language specialized to particular application domain. This is in contrast to general purpose language. So the domain specific programming language allow network operators rather than manually configuring each network device to program a network as a whole. So it will allow the network operators to program a network as a whole regarding each network devices. So Frenetic was designed to solve challenges with the use of open flow based model by working with an abstraction at the network level as opposed to open flow. So it worked with an abstraction of the network level as against or as opposed to open flow. In open flow, we know that which directly goes down to the network element level. So phonetic include an embedded query language, and we know that the embedded query language is a method of combining the computing power of programming language and the database manipulation capabilities of SQL. So phonetic is similar to SQL language. So this language, as we discussed now, it's similar to SQL and includes the segments for selecting. So select is a query language. In SQL, we select, we can filter, we can split, we can merge, and aggregating, combining the stream of packets. Another special feature of this language is that it enables the queries to be composed of the forwarding policies. So enable the queries to propose with the forwarding policy. And the compiler in phonetic produces the control messages needed to query and tabulate the counter on the switches. Students, we discussed the counter on the switches in lecture number 4. So counter, we know that updated for matching packets in that particular flow. So a set of counter in a switch that tracks the number of bytes and packets. So the counters, we already discussed the type of counters. And what are the type of counters that we discuss is the open flow or table counters, flow counter. In table counter, for example, how many packets are matched or packet lookups. Then flow counters, the packets or byte received. Then port counters, the packet bytes transmitted, received, and drops. So students, phonetic consists of two levels of abstraction. Here it's shown two levels of abstraction, as shown in the figure. The upper level, which is the phonetic source level API, here, which provide a set of operator for manipulating the stream of network traffic. The upper level here, but the lower level of abstraction is provided by a runtime system that operates in the SDN controller. Actually, students, the phonetic translate high-level policy and queries into low-level flow rules, then issue these needed open flow command to install these rules on these switches, on the switches. So as we discussed, it's a query language. Phonetic is a query language like SQL, and it provides the means, the ways for reading the state of the network and merging different queries. Like in SQL, we know that SQL, we can merge different queries. In the same way in phonetic, it can merge different queries and expressing high-level predicates for classifying, make the classes and filtering, transforming, and combining the packet stream which is traversing in the network. So the lower level of abstraction, as I discussed earlier with you, is provided by a runtime system that provides in an SDN controller. It translates the high-level policy and queries into low-level flow rules and then issues the needed open flow command to install the rules on these switches over here. So students, the details is available on the book given Foundation of Modern Networking by William Stirling. Good luck, and if you have a question, please feel free.